fixed it. Hi, I'm H, and I'm a software engineer at Human Security, and we protect the internet from cyber fraud. I work in the detection, analysis, and investigation team, basically working on detection, analysis, and investigation tools to help the detection, analysis, and investigation. Oh, that's interesting, isn't it? By the way, this presentation will be filled with lies and total fabrication, or what I mean to say is that some things I cannot disclose, so I may just skirt around the edges on some of the stuff. There will be no live coding, because I'm sure you'll be happy to hear about that, but there will be questions, not you of me, but me of you. I'm going to be asking you questions, so I want audience participation. Yay, brilliant. I know you can't wait. So what is the mission? Well, a very simple mission statement that we have here at Human Security, and that's to protect the integrity of the internet by verifying the humanity of every online interaction. See, and what we can do by doing that is we can disrupt the economics of cybercrime. All well and good, but what is the actual problem? What is the problem? So it turns out that a high majority of internet exposures happen to be carried out by bots. Who would have thought? And so by stopping those bots, we stop the threats. And the threats are across a whole host of different areas. For instance, in marketing, if you can insert yourself into the digital advertising supply chain, well, then you can get a bot to click or view ads and pretend to be human. And by doing that, you basically get some of that ad revenue. Oh, that's interesting. Not only that, websites, applications, there's a whole host of different things like credential stuffing, credential cracking, account takeovers, or account creation fraud, payment fraud, even content and experience abuse. There's a whole host of things. I'm not even going to talk about how many people hold up hands, how many people have tried to purchase a PlayStation 5 or have tried to get tickets for Glastonbury, but just can't do it because of scalping, because of bots getting in the way. Oh, bots holding inventory, even that, you know, just discarding the cart later on, even that interrupts the economics of like an e-commerce site. Oh, there's so many things that bots are causing. So, oh, sorry, I just now moved all the pictures of people around because they were getting in the way of my slides, but now I can see. Cool. So what is the solution? What is the solution to protecting the internet from all these bots? Do people know? Yes, it is the I am not a robot checkbox. Thank you very much. It's been a pleasure having me. Are there any questions? Okay, so maybe not, because that's how it used to be. Having a capture in front of an interaction used to work, but that was when bots were simple. It's no longer like that. Today's bots are actually not living in data centers. They're predominantly on users' devices, and they can mimic and fake. For instance, someone logged into Facebook and having a particular device ID. So it's becoming more and more difficult to determine whether something's a bot or not. And in fact, in olden times, they used to, olden times, it sounds like, you know, in the medieval ages of 2010, bots behaved like bots. They had interactions which you could tell were bots, but now we have replaying of actual normal human behavior and pretending to be human. And in fact, it's no longer the guy sitting in his bedroom manufacturing a few more clicks for his AdSense account. It's actual organized criminal activity with executive teams and working on products with a product roadmap and 2-week sprints. It's far more sophisticated now than it used to be. So what is the solution? Good question. Let's think for a moment. Oh, here's an empty box. It must be a whiteboard session. Brilliant. We're going to draw boxes on a whiteboard and we're going to fill in these boxes and sort out the solution. So let's say we have a website and we've had an interaction with the website and we don't know whether it's a bot or not, bot or human. So what can we do? And this is where I throw it open to the crowd to ask, what do we do? how can we determine if it's a bot or not?
Ask it was one suggestion.
Ask it, yeah. So, well, that's effectively the same as the capture. That's one way. So, when someone, let's say we're running a website, what kind of things can we look at to see characteristics of the traffic? This is going to be a long night. A weblog, you say? Sorry, I haven't got chat open because I've got so many.
You could ask the user to verify their identity with a different device.
Oh, a different device.
MFA.
That's nice. But what happens if we're just, you're just surfing the internet and you just come across, you're going to Amazon or something and you're just surfing for a product. You're looking for a particular product. How do we know if that interaction, even that just looking for a PlayStation 5 on Amazon, I don't know. How do we determine if that is a person or a bot? Because we're not even at the point where a fraudulent action can happen. So if you're running a website, we have logs. Yeah. Yay. Yes. Okay. What kind of things can we get from logs? What kind of information?
Source IP.
Oh, IP address. Nice one. Yep. Anything else?
User agents.
Oh, user agents. Okay, let's stop there. And I didn't prompt you, Rich, but you've answered two of the really easy ones to have, IP address and user agent. They appear in the weblog. We also have time when the actual interaction happened. Yeah. So let's call those things signals. That's fairly straightforward. I've got a little tiny screen here and there's got lots of windows everywhere, chat and people's video and everything. So I apologize. So what do we do next? Unfortunately, I clicked on the button and it said, put those signals into a data store of some description. So we've got an IP address, we've got a user agent, we've got a time of day, and we're going to store it somewhere. So let's say, let's put it in an Excel spreadsheet. Oh no, wait, because we want to make it available to lots of people, not Excel, let's use Google Sheets because also that scales. So that'll be brilliant. Yes. So we'll put all our data into a Google Sheet. Awesome. So what next? What are we going to do with all that data?
You have to analyze that data, one would assume.
Awesome. Yes, we're going to analyze that data with what I'm going to call magic algorithms. I'm not going to disclose what these magic algorithms are just yet. But yeah, we're going to have to do some kind of processing because we've got signals coming in, we're storing them, we're going to do some processing on those signals. And then ultimately, after that, bear with me a second, yes, we'll actually get that bot or not decision. Yeah. Oh, hang on a second. This seems like let me go back here. This seems like a long trek from here to here. And so we've got signals coming in. How many do human get? 10 trillion, was it? I say 10 trillion a week. Oh, hang on, 10 trillion signals a week coming through here. And we need to get a decision. I haven't told you this, have I? Our actual SLA for a response to get a bot or not decision is going to be 10 milliseconds. What does that suggest about the data here ending up over here to provide an answer in 10 milliseconds?
Those algorithms really are magic.
They really are magic, aren't they? There must be some kind of cache-in or pattern recognition or something like that, which makes us determine that something's a bot or not. And effectively, the reason why we're storing the data is so we can do more research. And yes, we have researchers who can look at that data later on. They don't have to do it in real time. We can get lots of data and in the end create a decision. I'm going to call it a decision matrix, but that's not necessarily what anyone anywhere who would work in this kind of industry would use. I'm being serious on that. We surely wouldn't use a decision matrix. That sounds like a really cool idea. I'm going to think about that one. Anyway, so signals come in, we store them, we do some magic, and then we make a decision and we allow people to look at stuff. Incidentally, working in DAIT, detection, analysis, and investigation tools, this is the section here which I particularly work on, helping out some of the guys with the research, getting access to the data store and moving some of that data store through the magic algorithms. And yeah, that's pretty much it, all I do. So no questions about signals or bot or not decisions, thank you. I've got no way of answering them. Well, maybe I can, we'll see. So that is the area which I work on. But what about these bits? What about these connections in between? So 10 trillion signals coming through, 10 trillion signals coming through per week through one end. What does that say about this bit here? What is this? All those who work at building things at scale.
You'd need some kind of distributed system.
Oh, that sounds good. Yeah, or
load balancing.
Oh, yeah, load balancing will play a part of it, I'm sure. Yeah. What's that you say? Oops. Oh, yeah, we're going to talk about glue. This is what the arrows are pointing at. It's the glue. So this bit here, I've got a lot of lag on my screen. Actually, this bit here, queue, batch processing. There's no way we can take in a single, that's so many signals coming in at such a rate. It's going to be really difficult just to move them into this data store. And now I'm thinking that we're going to have to upgrade this data store from Google Sheets to something else, probably SQLite or something like that. I can't think of any other database systems, Fox Pro or something. I don't know, maybe run it on 2 Raspberry Pis, we'll see. Well, as we get through, we may change the design of this. But here is some, oh, I know, yes, let's use Postgres. What a cool idea. I'm going to have to move these boxes out the way. This is really annoying working on just one screen. Incidentally, I'm at an offsite, and so I haven't got my normal computer setup of 100 screens around the room. So here we have some, this better not be production code. I'm sure it is production code. No, surely not. Of how we can insert signals into a Postgres database. Can anyone see the obvious mistake? Yep, you're right. It's no one's going to use green screen anymore. The cool kids all use amber screens. So that was the obvious mistake. Okay, so fair enough. We're working in a cybersecurity company. It would be remiss of me not to mention a thing about SQL injection attacks. And yeah, there's probably some exception handling which you've got to put around this as well. So here we go. I've tidied up the code nice and quickly. This is effectively what you do. You create a connection and then you insert into the table. We're going to call it signals. I'm going to call it, yes, why not, signals, and execute menu, because that way we can take a list of signals and we can insert them in all in one go. Can anyone see the problem with this?
If any piece of that data is invalid, the entire transaction fails.
Oh yeah, possibly. Yeah, that's. I remember we've got 10 trillion of these coming in every week, so this list is going to be a bit big as well. So it's going to be quite difficult to handle all this. So here's a bit of a clue what we can do about this. The database which we use. I mean, a database which someone could use is Snowflake. We do use it. It's on our website. I'm allowed to disclose that. The database we use is Snowflake. Now, a good thing about Snowflake is it takes objects stored in S3. Other cloud providers are available, stored in S3, and allows you to reference those objects as if they were through SQL commands. So it's as if it's a database made up of stuff on S3. Other cloud providers are available. That's crazy. But what it does allow you to do, it allows you to change this from a process which a bunch of workers pulling information off of a queue and inserting into a table of some description into something far more interesting with Snowflake. Oh, incidentally, Snowflake has a Python connector. How cool is that? Python ubiquitous. It has a really cool thing, because what you can do is push all your data straight into an S3 bucket and then just execute this, copy into table, and it does it all for you like magic. and you can transfer a ton of records all in one go. Whew. We should use this more often. Oh, yes, we do. Okay, so we've got a ton of data moving over into Snow. In fact, so this bit here, we can just have a pipe which pushes data into S3. And in fact, there's a better way. There's a thing called Snowpipe, and it effectively just chucks the data straight into Snowflake from an S3 bucket, other cloud services providers around, yeah, et cetera, et cetera. Ah, yes. Okay, so what about this bit here? So in terms of research, we want our data scientists to be able to access this data in this Snowflake thing. It was much easier when it was an Excel spreadsheet. Now it's the whole table. What are they going to do? Well, like I said, there is a Snowflake a connection available in Python, but there's something even better than that. Rather than doing something like this, where we set up a bunch of results, doing a normal execute of this SQL statement, something which is much better, much more efficient, or especially for data scientists, you can fetch the data straight into a pandas data frame. These data scientists are going wild and crazy, going over the moon because of this wonderful, wonderful feature. Now they work in an environment where they're quite used to data frames, Jupyter notebooks. This is so cool. Pandas is great. Snowflake is great. What a wonderful combination. Oh, yes. Quick, I've disclosed another password. So that allows researchers to access the data and do their data science magic. I'm not a data scientist. I'm just a lowly software engineer. Anyway, what about this bit here? Whew, we're going to take the data from that Snowflake thing and do stuff and do a bit of the magic algorithms. Well, anyone heard of Airflow? So Airflow is just a wonderful way of doing a pipeline, a flow of work. Oh, that's it. It's kind of like intimated in its name, isn't it? Which is pretty cool. So Airflow comprises of a thing called DAGs, which is directed acyclic graphs, which is effectively a bunch of tasks, one after the other. And in this case, this very simple example, we've got a scheduled DAG which runs every day at a particular time. I haven't set up the time of day on that, but that's one of the parameters. And we've got Python again. Oh yes, Airflow. It's all written in Python. How cool is that? So we can interact with it in Python. More Python, you say? Yes, I'm so glad I'm at the right talk. You can have a Python operator which effectively just runs a method which you can define somewhere in some other module. Or in fact, if you wanted to, you could subclass this Python operator and create any kind of a set of instructions that you want to define. How cool is that? Once you've defined each task, you just say a very interesting bitwise operation to describe how your DAG looks, and you end up with something like this. So in this case, task 1 would run, and when task 1 is finished, task 2 will run. So taking all that data from the Snowflake, putting it into the magic algorithm stuff, here's an example of something I've been working on recently. Names blurred out to save the innocent from being accused of using really bad DAG names and task names. This is something that takes data from one end and does some things. I'm sorry, I'm being very vague, and then combines the things and then puts them together and shoots them out the other end. And there's probably some magic amongst all that. Magic algorithms, you say. This is what we want. This is what everyone has come to see. The magic. I'm really sorry to disappoint you. There's no real magic. Well, I suppose there is. So let's assume that we've got an application running on a mobile device. As an attacker, as someone who wants to take over the mobile device, it's really difficult for them to know exactly the parameters of how the app would work in different places, like the thing they're trying to mimic. Let's say they're trying to pull in some ad content and pretend to click on it. Now, if you've got a lot of data, remember that we've got this huge data store, 10 trillion interactions a week, or whatever the number is. And we've been doing this about 10 years. That is a lot of data. So we know what a particular app's kind of like pattern of use would look like. So for example, and like in terms of an attacker, something which they'd have difficulty with is they can't say, well, what is the device distribution for my app? It's not the kind of thing you can search for on Google. It's only data that you can have if you've been doing it for a long time. Oh, thank goodness we've been doing it for a long time, because what we can do is we can see if when we see the user agent, for example, from that we can get the device name as a kind of indicator. And if we're seeing that in the history of all of our data that we've collected, that everything is in blue, when it turns out that the device usage comes in and it looks like it's in red, well, that's like a bit of a red flag. And we go, oh, hang on a second. And this is called like foreground background analysis. What is the background? What is the general state of affairs across the whole ecosystem? Comparing that with a particular pattern of usage. And we can say here, this looks like it's a bot because it's in red. Does that make sense? Of course it does, because you're all very smart people. How do we do this? Well, we could brute force it. Obviously, we've got data. We do select user agent from such and such over a particular date range. Well, yes, but we're talking about user agent and IP address and time. Perhaps there's a few more signals than that. Maybe one more, I don't know. But either way, the more signals you add to this whole list, the more complex this whole arrangement becomes. So then it comes down to, excuse me, then it comes down to using something like, it's effectively a clustering and a classification problem. And that's, if you do scikit-learn, download that, import from sklearn cluster.cluster. If you import, there's probably a bot or not clustering mechanism. Surely there must be. And if we select the timestamp and IP address and user agent from the signals database, put it in a data frame, and we can apply this clustering magic. It's not really magic, is it? It's just data science. It's machine learning. It's problems that have already been solved by things we can import. Full disclosure, there probably is not a bot or not clustering tool in scikit-learn. Just to disappoint you, I'm sorry about that, but it's part of the magic. I'm giving you the principles. So for instance, if we had timestamp and IP address and user agent, we can do things in terms of our clustering. We could find that we have usage patterns in a particular time zone. And we know that, for example, for this one particular package, everything happens in the America Los Angeles time zone. We get that from our history and from the clustering, and the usage pattern of the traffic we suspect to be invalid, that is falling in the red zones. So that's potentially a bot. Oh, that's interesting, isn't it? Yes, it is. I'm so glad you listened all the way through. So, in summary, collecting loads of data, pushed into a very big bucket of probably 2 spreadsheets on 2 Raspberry Pis, but you can access it through pandas, through Python. And Python seems to be the glue that holds all these pieces together. It's the part that injects the data into the tables. It's the part that data scientists can use to manually interact with the data. It's the part that moves data through the process, through the magic algorithms. Guess what? Some of the magic algorithms are machine learning. Yes, they are. And with or statistical analysis. And there's libraries and modules throughout the whole Python ecosystem that provides that. That's pretty much it. So are there any questions?
What's the biggest incident that human has been involved with?
Oh, the biggest incident. That's interesting. They're getting bigger and bigger all the time. So bear with me a second. See if by the way, we're hiring. Small plug there for all the smart people who answered questions and helped me design that whole flow. Whether that's the real workflow or not, who knows? But it definitely involves Python. We are hiring. But I'm glad you asked that question about the biggest cyber fraud. So back in 2016-ish, there was a thing called Methbot. 2018, a thing called Eve. We actually had a conviction fairly recently. One of our main guys actually was one of the expert witnesses, and had to describe to a judge and a jury in layman's terms something which is incredibly complex in terms of how bots work. Methbot itself was named because some of the code used had the term meth in it. It enabled bots to watch 300 million video ads every day, and they spoofed 6,000 premium domains. When I say premium domains, they were things like Time Warner, although it may not be Time Warner .com, but they were spoofing domains where you'd expect this data to come from. Businesses paid more than 7 million for ads. This is in the indictment. Eve was 1.7 million infected computers, 10,000 domains spoofed, 12 billion fake ad requests per day. This is costing businesses money day in, day out. And another recent one, which, and by the way, all this has been, we've got papers, white papers and everything on our website describing all of these. Pareto was infecting 1 million or so Android phones, targeting smart TVs, connected TVs, pretending to watch ads. CTV cost per ad is actually much higher than it is for mobile and it is for web. And so the bot ecosystem is moving over to where do you get the biggest buck? You see, we're trying to disrupt those economics, so it makes it harder for the criminals to actually make money, which then in turn tries to prevent all this fraud. Yes, 650 million daily bid requests. That's what we observed through our connections and our system. So yeah, thank you for asking that question. Those are just recent ones. I see there's other questions in the chat. Right. For a new service without 10 years of data, how would you judge how much data would you need to collect before you can classify accurately? I'm not a data scientist. The answer is a lot. Apologies for the flippant answer, but it is really difficult to get into a place where we are right now, purely because the founders of the company had the foresight to see that criminality was, in the increase, and we had a very easy way in through ad fraud. It's something that we can show is there, and it's something which doesn't actually cost the customer that much more because they're actually recouping the cost of their lost advertising back, and we're just taking it back away from the criminals. So that's pretty cool. But how would you judge how much data how would you judge how much data would you need to collect before you can classify accurately? So even, yes, that's an interesting question. It's that when you've got data, the outliers, are they outliers, or is it normally part of that normal distribution that you have, and they are not necessarily outliers but just on the edges? So it's a difficult question, and I think that the answer is you have to have the history to get there. What are the best resources to learn about the statistical analysis learning your phone uses in the magic algorithm section? What are the best resources to learn about? Pascal, we are hiring. Feel free to apply for any of our data scientist roles, because that would certainly I can't give you any specifics about the magic algorithms. But if you look at all the even just standard k-means or or k-nearest neighbor, so for clustering and for classification, even starting at those simple steps, of which the libraries, just have a look in sklearn, scikit-learn module, you'll find loads of information and loads of statistical analysis that you can use, statistical models that you can already use for clustering and classification. I hope that's answered to the best of my ability. And yes, stressful experience. No, it's a wonderful joy. Working at Human, actually, it's pretty cool. We've actually got an offsite at the moment in London, which is why I'm not with my normal setup, and I'm with a tiny laptop, because I wanted to make it easier to carry.
So for those who might be interested in joining Human, is the tech stack predominantly Python, or is there opportunities to use other languages so you can do buttons rather than just backend?
I don't know if we allow people to do buttons. People doing buttons have to have at least 4 weeks worth of experience. That's an in-joke. So because what we have to protect is everywhere, we have Python is our predominant glue. We do have a lot of code in Python, but we also have a lot of Golang code. We also have like some of our integrations, of which there are many, all available on the website. Have a look. We have even languages like Rust are being used. We've got obviously that JavaScript thing, so anyone who knows buttons, that would be cool for them. There's mobile stack, so Objective-C, Swift, Java. There's a whole host of languages that we use. So it's not just Python. And in fact, it's we're hiring across the board, rapidly growing. We're a US-based in New York. We've got a London base, Argentina, Canada, and lots of remote working opportunities as well. So yeah, it's not just Python.